stuff. Piecewise functions are one of the favorites for the College Board, so therefore it's going to be one of my favorite also on the midterm. Every time I get a chance to hammer you in piecewise functions, okay, you're going to get it. X is greater than 1. Alright, they're asking you, is this function continuous at 1? And what type of discontinuity do you have? Okay, before we get to check and see if it's continuous, here's the different types of discontinuity. Okay, if you have just a hole, that's a removable discontinuity. If you can fill in the hole, make it connected, then it's a removable discontinuity. But if you have a hole but that jumps from one place to the other, that's a non-removable discontinuity, and it's to be specifically called, it's called a jump discontinuity. So but it's non-removable. Okay, and then if you have a vertical asymptote, okay, then it's a non-removable discontinuity also. Okay, and that's called infinite discontinuity. But what I need to know is removable or non-removable. Okay, first of all, at 1, that's what we're checking. If this function is continuous, then the limit has to be the same both from the left and the right side, and the value of the function at that instant has to be exactly the same. So let's find the limit, and you have to show all this work. You can't just say I did it in my head. As x goes to 1 from the left side, okay, which one do I use for that one? First one, which is 2x plus 1. Okay, plug in 1, which becomes a 3, right? 2 plus 1 is 3. And then we're going to check the limit as x goes to 1 from the right side. And I use to the right side means it's to the right of 1, and that one is the bottom one, x squared minus 1. So when I plug in 1, this turns into 0. So automatically I know it is discontinuous. But what kind of discontinuity do I have? Okay, and I also know it's going to be jump discontinuity. Why is jump discontinuity? Because this is the bottom one, the parabola. When we go to 1, the parabola is going to 0. So the parabola coming from the right, the parabola is doing that. Okay, and then when you go to the one from left hand side, okay, it's a line. Okay, the line is going to 3, so it's going to do that. So it's jumping from one place to the other. Alright, so we don't even need to check what is f of 1. If it was continued, if it was, this turned out to be the same, you'll have to check. Okay, so this is a non-removable, okay, discontinuity. That's all I need to know. Alright, number 3. Number 3, I have f of x is equal to 2x plus 1 when x is less than 1, and is 0 when x is equal to 0, and I have 1 over x minus 1 when x is greater than 1. Alright, is f continuous at x is equal to 1? If not, what type of discontinuity? Again, we're checking from left side, right side, and the value of the function. Well, we already know what the value of the function is. It's f of this is 1, sorry. We already know what the value of the function is at 1. And what is the value of the function at 1? It's 0. We know that. Now, it will be continuous if the both left side, right side turns out to be 0 also. So let's check. Limit as x goes to 1 from the left side. Which one do I use for that one? Top one, which is 2x plus 1, which is going to give me 3. And then limit as x goes to 1 from the right side, I use 1 over x plus or minus 1. Okay? Uh-oh. Okay. I can't plug in 1. Why is it I can't plug in 1? 0 on the bottom. What do you get on the graph when you get something like that? You're gonna get negative infinity actually, because you're gonna put in something really close to 1, like you're right. What, positive infinity? 1.0001. You're gonna get positive infinity, that means it's going to have a vertical asymptote. Okay, it's going to have vertical asymptote. It's non-removable discontinuity. Okay, so it's a non-removable discontinuity. All right, Macy, you good? All right. Let's go to section 4. Questions on section 4. 1. Yeah? Teresa? Are you awake back there? Number 3. All right. 1 and 3. Okay. Let's start with 1. Okay, they give you a graph that looks something like this. You got that at -1, and this goes to -1, and then you got a graph that starts here, and then goes through there, and then you have an open circle at 1, and that value there is 1, and then this jumps up, and then it goes up, and this value here is 2. It's my y-axis, it's my x-axis, okay, and this is what the graph looks like. Alright, looks like I got everything I need. Okay, it says graph of the function f is given, f of x is given in the figure below, at which points f is discontinuous. Well, that's obvious that f of x is discontinuous at x is equal to, and this is x is equal to what? -1 and 1. Okay, for each point of this continuity found in part A, determine whether f is continuous from the right, from the left, or neither. Alright, this is B. When I come from the left to -1, okay, limit as x goes to -1 from the left hand side, okay, when I'm coming from the left, is the hole filled in? Yeah. Then it is continuous from the left. Not from the right, but from the left. Okay, when I come from the right, I'm going to -1. Is the hole filled in? No. Okay, limit as x goes to -1 from the right side f of x. Okay, it is discontinuous. Does that make sense? Okay, now we'll go to the 1. When I come from the left to 1, is the hole filled in? No. So limit as x goes to 1 from the left side of f of x, it is discontinuous. And then when I come from the right, okay, is the hole filled in? Yep, that means it's continuous from the right at 1. So limit as x goes to 1 from the right side, f of x, is continuous. Right. That is it for 1. So let's go to number 3. How are you doing there, Carl? Is that what it is? Okay, I didn't know what that blank stare was. Thought you were just dazed and confused. Alright, 3. F of x is equal to x plus 1 when x is less than or equal to 1, and 1 over x minus 1 when x is greater than 1. Folks, the top one is a line. The bottom one is a... You got a vertical asymptote there, right? You're going to get some kind of hyperbola, correct? Alright, vertical asymptote at 1. Okay, let's check it out, see what they're asking us to do. Okay, in this one, they're asking us to say, sketch the graph. Okay? Let's sketch the first graph. Make sure you get comfortable. You better not have your shoes on my couch. I don't care about touching. But I have my You better not have your shoes on the couch. Yeah. Alright, so this is a line with a y-intercept of 1 and then slope of 1, 1. So up 1 over 1, you're going to get a line like that. Okay, and it looks like that. Any questions? This is 2. And then to the right of 1, you're going to have vertical asymptote at 1. Okay, and when I come from the right hand side, this is where you have to use the limit to figure out which way it's going. Limit as x goes to 1 from the right side, 1 over x minus 1. Is the bottom getting small positive or small negative? Small positive. Okay, small positive, because you're going to put in what number to check? 1.00001. If the bottom gets small, the whole fraction gets what? Infinity. It gets really big, so it's going to do that. Now you also have to check this. Limit as x goes to positive infinity. That means we're checking the end behavior. And this is easy. When bottom gets really, really big, what happens to the fraction? Really, really small goes to 0. So it's going to flatten. It's going to have a horizontal asymptote at 0. That's what the graph looks like. Alright. So we're done with the graph. So now say at what points is f discontinuous? So this is part A. So part B, clearly it is discontinuous. F of x is discontinuous at x is equal to 1. C. For each point of discontinuity found in part B, determine whether f is continuous from the right, from the left, or neither. Okay. In C, okay, f of x is continuous from the left. Does that make sense? Because when you come from the left, is it closed right there? Okay. And then when you come from the right, f of x is discontinuous from the right. Okay, that means when I come from the right, it's not going to be connected to anything. It's going to go on forever and ever. Okay, so the vertical asymptote will make that discontinuous from the right. Okay. Now, D. Classify each discontinuity found in as a removable discontinuity, jump discontinuity, or infinite discontinuity. So, when you have vertical asymptote, what kind of discontinuity is that of the three? What is it? It is non-removable, but they were more specific here. They said removable discontinuity, jump discontinuity, infinite discontinuity. Infinite discontinuity. Why is it infinite discontinuity? Because it's going to what? Infinity. How you doing there, Caro? Did you take your medication today? You're a little antsy. He's jumping all over the place. Alright. Section 5. Section 5. Is that the same thing? Similar graph, huh? At section 4. Alright, what would you like to see section 5? Macy? 1. Ivan? 4. 2. Ivan, didn't I do 4 in the notes? Yeah. Check the notes out. I did. I have it marked here. Alright, number 1. It's the same picture we had before. Okay, Okay, the graph of the function is given in the figure below. Determine the intervals which f is continuous. Holy cow. Holy cow. Remember, you guys can't say that because it would be politically incorrect. But I can say that. No, you can't. You're insensitive to my culture. I'll get the cultural police on you. And this point is 2, 6. And this point is 1, 3. And this point here is -1, -1. And this point here is -1, -2. Okay, and this is 6. And then finally this point here is -2, -8. Okay, and this is -2, and that point is -8. Alright, where's it continuous? Look, it's continuous to the right of -2 up to -1. So that means continuous on the interval, open interval at -2 and closed interval at -1. It is union, it's continuous in between -1 and 1. So union of -1, parentheses, -1 and 1. And it's also continuous from here to here, so union of the closed interval from 1 to 6. That's where it's continuous. What's that? Yep. I love the union. Okay. So that's it for 1, so let's go to 2. Number 2. F of x is equal to x plus 1 when x is not equal to 0. Okay, 2 when x is equal to 0. Okay, determine the intervals in which f is continuous. Okay, so basically you have a line, and let's sketch the graph of that line. Okay, and the line is, the y-intercept is 1, the slope is 1, 1. Okay, and you have a line that does that. But this line only exists everywhere except at 0. At 0, this line does not exist, so you get an open circle. At 0 itself, the graph, the value of the function is 2, so that's at 2. Okay. Where is this function continuous? Okay, f of x is continuous from the open interval -infinity to 0, parentheses, union from 0 to positive. That's it, huh? We're good? Alright, section 6. Oh, L'Hopital's rule. You guys are going to love L'Hopital's rule. Easier than doing algebra. If you don't know how to do algebra, find limits, L'Hopital it. I can teach it to you before. Technically, this is not part of the Calculus AB curriculum. It used to be. They moved this to BC. Okay? But if I teach you 0 over 0, infinity over infinity, okay, you can use a lot of this on the AB test when it shows up without doing a lot of algebra. But when you get to BC, you're going to also take in consideration when you go to 1 to infinity, 0 to 0, you know, stuff like that. Okay, but right now we're not going to worry about anything else except just these two situations, because that's all you're going to see on A/B test. Okay, all right. So having said that, L'Hôpital, La Hospital, section 6. Actually, a French mathematician, Jacob Bernoulli, I believe it was Jacob Bernoulli, there was like a huge family of 6 mathematicians, and L'Hôpital was a rich kid's son, and they wanted Jacob Bernoulli to tutor him in calculus, and he tutored him, and Jacob Bernoulli, I think it was Jacob, but one of the Bernoulli brothers taught L'Hôpital this rule, and after Bernoulli died, L'Hôpital claimed it was his, and ever since then it's been called L'Hôpital's rule. Some kid waited till the teacher died and said, "Oh, I came up with this rule." Okay? Alright, what would you like to see in section 6? Teresa. 2. 3. 9. Anything else? Alan. 10. What? 7. Alright, let's start with 2. Let's take a look at 2. Limit as x goes to 9, okay, x minus 9 over rad x minus 3. You're going to put in 9. That's how you find limits. You're just going to put in numbers. But if it doesn't work, right now you're going to get 0 on the top, 0 on the bottom. You have 2 ways to go. Back in the day, we did algebra. So just for back in the day purpose, I'm going to do algebra first, and I'm going to show you L'Hôpital second. Limit as x goes to 9. We factored this. This wasn't a quiz. Okay, rad x minus 3 times rad x plus 3, because that's the difference of 2 squares. And then you have a rad x minus 3, and they canceled. And then you took the limit of this as x goes to 9 of rad x plus 3, and then when you plug in 9, okay, it turned into a 3 plus 3, which is 6. Okay, that was fairly easy. Okay, but now if you use L'Hôpital's rule, you have to establish this first before you can use L'Hôpital. You have to either get 0, 0, infinity, or infinity. Okay, now I can take a derivative of this. I am not using a quotient rule. Okay, so don't mistake this for a quotient rule. I just take the derivative of the top. What's the derivative of the top? It is 1. When I take the derivative of this, that's going to give me 1/2 x to the negative 1/2. Okay, so, and the derivative of negative 3 is 0. So I can take this, move it to the top. So limit as x goes to 9, I have 1 over 2. Okay, and when I move this to the top, I'm going to get rad x on the top. Okay, this is 1/2, not 2. Sorry, 1/2. Alright, now plug in. When you plug in 9, you're going to get 3 over 1/2, which is 6. In this one, algebra is probably much easier. Okay? What do you think, Carl? Are you still awake back there? What's that? I know. Yeah, get it right this time. Number 3. Limit as x goes to 3 from the right side. X minus 3, all that over square root of a x squared minus 9. Alright. Now, if you want to do the algebra, you're going to have to rationalize the denominator. Or, when you plug in 3 on the top, you'll get 0. When you plug in 3 on the bottom, you'll get 0. Which way do you want me to go? Algebra is also easier for this one. So let's rationalize the denominator. Limit as x goes to 3 from plus side. I have x minus 3 times radical x squared minus 9. And when I multiply the bottom by radical x squared minus 9, that's going to become x squared minus 9. Right? Gets rid of the radical. Just rationalize the denominator. Of course, this now splits into, okay, x minus 3 and x plus 3, correct? So because of that, this reduces, and I have a limit as x goes to 3 from the right side, rad x squared minus 9, all that over x plus 3. Correct. Okay. I'm through with algebra, and I'm going to plug in again. When I plug in on the top, that's going to give me 9 minus 9, which is 0, over 3 plus 3, which is 6. The answer is 0. That's where the function goes when it goes from the right-hand side to 3. It's going to go to 0. Okay. Number 9. Number 9. Alright. We're finally getting into this. As h goes to 0, this is a tricky question. It shows up on the AP test all the time. Okay? It might even show up twice in a multiple choice. They love this so much. You probably think they're asking you to take a limit, but they're not. You can. Okay? And we did this before by using limits. But this is actually finding a derivative of a function. That's what this is. If you remember, okay, limit as h goes to 0, f of x plus h minus f of x, all that over h. Okay? That's the limit, that's f prime of x. That's what the derivative is. And you have to recognize that's what this function is, the derivative. But you're going to say, well, this should be my f of x, but why do they have 1 there? Okay, the reason they have 1 is my f of x happens to be x. So what is f of 1? If f of x is x, what's f of 1? Thank you. Okay. Alright. What is f of 1 plus h will look like? 1 plus h. But now we got this cube root here, right? So that means my f of x must have been not just x, it must have been x to the third. Okay? So if x to the third, then f of 1 plus h is going to be third root of that, right? Okay, so what they're really asking you is find f of x, which is x to the third, and then find f prime of x, which is 3x squared, and then evaluate that function at 1, which is 3. That's what that is. Okay? That's what that is. So if I put this on the test, you can do it the long way. And I remember one year, I think kid did it in L'Hopital's rule. Okay? You could do that. Or you could rationalize the numerator by multiplying by the conjugate, which also takes work. Or you can just say, oh, I know what my f of x is. I just take the derivative of that and evaluate that at 1. You could do that, which is what they're asking you to do. Okay? Alright. I missed 7, so let me go back and finish 7. Then we get to 10. So this is 7. Okay? Same type of problem. Limit as x goes to 4. Okay? As 1 over x squared minus 1 over 16, all that over x minus 4. Alright, you probably do not remember this definition because I went through it. There's 2 definitions for derivative. Well, actually, I'll write 3 of them because sometimes we use delta x. So f prime of x is equal to limit as h goes to 0, f of x plus h minus f of x, all that over h. That's the definition of derivative. F prime of x is equal to limit as delta x goes to 0, f of x plus delta x, okay, minus f of x over delta x. That's the definition of a derivative. Okay, there's a third definition, or actually a second definition of derivative, and that's limit as x goes to a, f of x minus f of a, all that over x minus a. That means the y values are going to 0 and the x values are going to 0. Okay, then you're going to find the slope at that particular point. Okay, this is given to you as a second definition because they actually give you a value, not a 0, a value. And if you look at this, my a happens to be 4. And what is my f of x then? What is my f of x? 1 over x squared. And they want me to find the derivative of this function at 4, because that's where it's going to. So let's go ahead and find the derivative of this function. So before you do that, you might want to rewrite. You don't want to use quotient rule, so let's write it that way. Okay, that'll be negative 2x to the negative 3, which is negative 2 over x to the 3. Okay, then plug in the value, f prime of 4, which is negative 2 over 4 to the third, which is negative 2 over, what is 4 to the third? And that's what the answer is for this one. Okay, negative 1 over 32. You want to do it the old-fashioned way, add those two fractions, do some algebra, reduce, okay, factor and reduce, and then you'll get the same thing. Alright. Number 10. Limit as x goes to pi over 4. Okay. Tangent squared of x minus 1. All that over x minus pi over 4. What are they asking you to do? This is the definition of derivative. What's my function in this particular problem? What's my f of x? Tan squared x. And what is my derivative? Well, you gotta use chain rule, don't you? 2 tan x times secant squared x. Okay, but they're asking me to find the derivative at a particular place. Where they want me to find a derivative at? Okay, pi over 4. Okay, which is 2 tangent of pi over 4, okay, which is 1, times 1 over cosine of pi over 4 squared, right? Okay, so this is 2 times 1, and that's rad 2 over 2. When you square that, you're going to get 1 over 2 over 4, which is reduces to 1/2, which flips and becomes 2. So you have 2 times 1 times 2, which is going to give me 4. Alright, the final section, section 7. Tonight's homework problems, I think, is going to be hard. This isn't bad so far. Let's see. Yep. Section 11's. Yeah, section 11 is going to kill you. Yeah. Okay, this is section 7, number 5, Amy, alright. Alan? Alan, say it. What'd you say? 3. Macy, do you have a question? Nope. 3 and 5. Jessica, you have any questions? Are you still with me? Okay. Sometimes I worry about you and Caro. You zone out on me, both of you. Alright. 3. Determine the limit. Okay. Limit as x goes to 0. 1 plus minus 1 minus cosine of 4x, all that over 9x squared. Alright. If I wanted, when I put in a 0 for the x, right there, cosine 0 is 1, 1 minus 1 is 0. When I put in a 0 on the bottom, I'm going to get 0. I can't find the limit unless I do some algebra. I could multiply by the conjugate of the top, which gives me 1 minus, which is 1 plus cosine 4x, which gives me 1 minus cosine squared of 4x. Then I use a trigonometry, which turns out to be sine squared of 4x. Then I got to multiply the bottom by the same conjugate, 9x squared times 1 plus cosine of 4x, and we can do all of that. Or we can just take a derivative of the top, derivative of the bottom. L'Hopital's rule will come in handy here. Okay, derivative 1 is gone. What's the derivative of a cosine? Okay, so negative and negative make that into a sine. Okay, of 4x times 4. Where am I getting the 4 from? Chain rule, exactly. And the bottom is going to be 18x. I'm not using the quotient rule. Okay, I'm taking derivatives separately. Then we'll plug in a 0. What's sine of 0? 0. 0 on the bottom. 0. Uh-oh. You just keep, no. L'Hopital's works. You might have to do it 2 or 3 times, but it will work. As long as you're getting 0 over 0 infinity. So here again with L'Hopital. Okay. So the 4 is on the outside. So what's the derivative of sine of 4x? Sine, okay, you're right, sorry. Cosine of 4x times 4. Then you still got this 4, which is a coefficient. All that over 18. Any questions? Okay. Plug in 0. What's cosine of 0? It's 1 times 4 times 4 over 18. That's the limit. Remember that really long, ugly problem where we had to like multiply by the conjugate and multiply the bottom by the conjugate? You could L'Hopital that, and that falls apart real easy. And that's when I told you, don't go to anybody ask questions how to do that problem, because they would just L'Hopital it. Okay? And that's what the kid did for you, right? Your brother said, just do the L'Hopital on this. Yeah. Because he was too lazy to figure it out algebraically. And then you said, what's that? Alright, number 5. Folks, they made it too easy on this one. It says limit as h goes to 0, cosine of pi over 3 plus h minus cosine of pi over 3, all that over h, exists. Determine if this exists. If it does, write an equation of a tangent line. What do you mean determine this exists? This is really definition of what? F prime at pi over 3. Isn't that what that is? That's the definition of a derivative at pi over 3. They just plugged in a pi over 3 right there. Well, they gave you a hint. They shouldn't have given it to you. They told you what f of x is. What is f of x? Cosine x. That makes sense, because when you put in pi over 3 for the x. So they want you to take the derivative of this. When you take the derivative of that, and it exists, negative sine x. There it is. And they want Now, how do you find the equation of a tangent line? Well, you have half a point. Okay? You have a half a point. How do you find the other half of the point here? Plug it in. What are we plugging in into the function? Pi over 3. And we don't have to draw the whole unit circle, do we? Okay, what's cosine of pi over 3? 1/2. So that's 1/2. So there's 1/2. Okay, now we're going to find the derivative of this. Derivative at pi over 3, which is negative sine of pi over 3. Okay, what is sine of pi over 3? Rad 3 over 2, which gives me negative rad 3 over 2. Okay, there's my slope, there's my point. That's y minus 1/2 is equal to negative rad 3 over 2 is my slope. X minus pi over 3. And those of you that love y is equal to mx plus b, keep going. But if you don't want that, you can leave it right there. Okay? Alright. So that's first 7 sections. As promised, the next section is going to be hard for you. So let's go ahead and work on that the rest of the period, and then I'll go over it with you tomorrow. Going up to 11, folks. Going up to 11.